Okay, in this video on projectiles, we're going to just give two pieces of information. The initial velocity of a projectile is 30 meters per second. And we'll keep acceleration as minus 10 meters per second squared, or ms to the minus 2. And let's see the amount of information that we can get just from these two things. So what about our equations that you're learning off by heart? Just keep writing them down on each page of your copy. S is equal to ut plus a half at squared. These are the ones we're going to use all the time. V is equal to u plus at. And v squared is equal to u squared plus 2as. We'll just leave it at these three for now. So what can we tell with u and a? Well, every equation seems to have more variables than this. But what do we know about these projectile questions? This one is going to get fired straight up in the air again, like the previous video. So we know at a certain point velocity is going to be equal to 0. So this is kind of your knowledge to get into the question. You know the projectile shape is like this if we graph the displacement, and at a certain point the height is going to reach a max height. Let's find out what that is in this video. It's going to reach this max height because velocity momentarily becomes 0 before stopping and turning back and going in the other direction. This kind of, we don't see this really point, it just comes down, stops really quickly and comes down. So v is equal to u plus at is a nice easy equation to give us the time taken to get to the top. When velocity is 0 and the initial velocity is 30 with acceleration of minus 10 times t, we can see that 10t would be equal to 30. So t would be equal to 3. And what I'd love you to get at this point is this little bit of knowledge here. Just sketch a quadratic up and down like this. Identify your max height. Your graph should be quite symmetrical. And put 3 for time here. We don't know this max height yet. We'll get it in a second. Along here, let's see what this point is. This is where velocity is equal to 0 along this line. Now, time is 0 at the beginning. What would you say time would be at the end here? Have a guess, look at the graph. You're right, it's 6 because these graphs are symmetric, and we're going to see this as well in this video. So let's look at displacement. S is equal to ut plus a half at squared. You'll never get sick of writing it. So the displacement, when my initial velocity is 30 and time is equal to 3, and we know we can put the half in like this, plus the half times minus 10, or you could just write minus 5 by t squared, 3 squared, and we just simplify it down. S is equal to 30 times 3, 90. You could type this whole thing into your calculator if you wanted. A half by minus 10 is minus 5, and 3 squared is 9. I'm thinking of 5 nines is 45. So S is equal to 90 minus 45. So the max height, the displacement when t is equal to 3 is 45, and we'll say meters. We're dealing in meters this time, so we can put a 45 in here. So let's find the other points on our graph. 30 times t is 30. 30 times 2, 60. 90. So you should start seeing a pattern once you start doing these tables. Minus 5 by t squared is minus 5 by 1. You might have seen these before. Minus 5 by 4, minus 5 by 9, minus 5 by 16, minus 5 by 25, and minus 5 by 36, the same as the previous question. And if we add these two numbers together, 30 minus 5 is 25. It's climbed 25 in the first second. Up to 40. It's only climbed 15. 90 minus 45 is the max height that we saw. So in that third second, it only climbed 5. 120 minus 80 is 40. You can see it's on its way back down. It's gone from 45 to 40. It's gone down 5. 150 minus 125 is 25. It's gone down 15. You can see it's mirroring off. and 180 minus 180 is 0. And we just put those points on the graph. After 2 seconds, it has a height of 40, and after 3 seconds, 45. So after 1 second and 2 seconds, approximately here and here, you can see climbing much quicker in the first couple of seconds. And you can just jot your values on here. 40, what did we have? 40, 45, 25, 40 and 45. 25, which looks about right, 40 and 45, and then the other points, they mirror off on the other side always, so you could draw a line across there. We'll be looking at areas and stuff under these curves, so it's important to have all of this knowledge. So nice little video on when the speed is 30, and you may think, well, what are the speed, different speeds? So you might want to make some of these questions up yourself at this point. Make up a speed between 0 and 100, do the graph, see what happens, and try and gain a bit of knowledge about these quadratic curves and these projectiles getting fired straight up in the air.